Hello, this video is going to continue going over player input and input action assets and action maps in the new input system in a little bit more detail this time. So in the last few videos we went over the player input send message, invoke Unity events, and invoke C# events. But I'm a programmer, and if you made it this far in these videos, you are probably also a programmer. And in this video, I'm going to cover how you would go about doing character input so that you get a run, jump, use character with these actions on it without using player input, which is a totally valid way to use the new input system. And in the next video, I will cover why it's actually really useful to use player input, but as a programmer, not just a Unity person that wants to mess with input action maps, but really likes strong C# structure. Okay, so I'm going to start this by removing player input because we don't need it, and opening up the character controller input script again. And look at all this stuff that we don't need. That goes away. Still need our character controller. This on-action triggered thing that I hate so much goes away forever. And all of these input action callback contexts are actually still kind of useful. But we're not going to trigger them from player input. We're going to trigger them directly from the input action map / asset. So the first thing I'm going to do is I'm going to get a reference to the input action asset, call it something like that. And on the Unity side, that means that I'm literally going to drag that input action asset we created onto that field. And this is where we take a bit of a detour into strings and correctly typing things in based on the data that's inside the input action asset. You could use references as well, and I think I will actually cover a little bit of that in this video. But the general idea is with character controller, with input action asset, you want to find an action map or a control scheme. In this case, we already know the action map we're going to use. It is the same one we've been using, which is called default, and it has 3 actions: move, jump, and use. So if we do a input action asset dot find action map default, this will return us a input action map type that we can then enable or disable. To enable or disable an action map, you can do map.enable. And this will enable any of the actions underneath that map. So in this case, that's move, jump, and use. So how do we get these callbacks out of there? Well, I'm actually going to start this by not using the callbacks. So I'm just going to comment these guys out. And jump right down here to fixed update, because this is an important part of having a reference to the actual input action and input action map, is that you can directly access the action and pull it, much like you would with the old input control system. So where before we were using an event and setting vector2 equals blah, 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 I'm going to bring these down here for reference, and I'm actually going to be setting move vector directly inside fixed update. So move vector dot x equals, I meant to cache this so that we don't have to do the find action map thing again. And now, because we have a reference to the map itself, we can go in and use the indexer property on this and say, I want to get the move action. And I want to read it as a vector2. And I want to read this part as vector2 and get the other component. So now we've effectively pulled an action to get our move input. So now when we go back in play mode here, we don't have any events firing, but we can still read our input. And this should start looking a lot more familiar to people that are used to using the old input system. And this is a totally valid way to do this. Where you get into trouble with this is when you start trying to deal with buttons like on up and on down and so on and so forth. So if we wanted to try to do on jump, do something similar. If character controller is grounded and map jump dot what? You can read the value, but that doesn't tell you, that just tells you whether the button is pressed or not. That doesn't tell you that it was pressed on this frame. So we've got read value, and unfortunately it's a float, so you'd have to do that. And this will kind of give us what we want. Hit the go button, and now as long as I hold down the jump button, every time it touches the ground, it'll jump. But what if I only wanted it to jump once until I pressed and released the button? This is where we get back into what's going on with the jump interactions. So from the previous videos, we added the press and release trigger behavior, interaction, to the jump action, and we set its trigger behavior to press and release, which means we got two performed events, one for a press and one for a release. So we could actually check if jump is pressed and map jump performed, it's performing, oh no, we can't. We can check the phase. So if the phase is equal to performed, then jump. And this looks and is a really roundabout way to say, hey, did my button get pressed? Jumping back into Unity, hit play, and again we should be getting a performed on press and release. So if I push the button down, we get a jump. And wait, why is it still jumping? That's because the action doesn't get unperformed. The action is actually still performed until you release the button when it gets canceled. So this doesn't only last one frame, it just stays set. And it's actually set on the same frame that you release the button as well. And the read value always returns 1. So this doesn't work. This is absolutely not going to work for polling buttons. So we still need an event to drive the on up and on down function with any reasonable amount of code. There's all sorts of polling you could do here, like storing the value on another variable and checking what it is between frames and rating your own events. And that's a whole other topic. But now that we've shown polling, we're also going to show events being driven without player input. So this is where we get into grabbing the jump input action and then subscribing to its performed event. And this is where we get into the, oh look, a function that already takes input action callback context, just like the other ones from Unity events and the C# on action triggered event. and then we can just give it that, and it will work the same way. So same idea, context revalue is button. If the context is performed, then jump. And now we get back to what we want. And again, our debug logs show that when we release, the phase is performed, trigger is true, value is false, because we released the button. The difference between this and what we showed with the polling is that the phase stays in perform, and when you read the phase again, it hasn't changed, it's still in the same phase. Whereas the callback only gets called back when the input action actually gets, for lack of a better word, triggered. And that's how you would normally go about doing that. So now we have polling for this, which, cool, this is the way it used to work, and that's okay. But if we wanted to go back to the event, our onMove event style, by using the event-driven action, which is, to me, kind of the whole point of the new input system, is to get away from polling every frame and really to have contextual callbacks about when an event happened, why it happened, was there a special interaction, was there a processor, what input device was it. All of that information is accessible through the context. So if we just go about our business polling, sometimes we miss out on some of the important information. So let's try it this way too. We can grab map move, performed plus equals on move. And this is half correct. Performed is called back when the input action is performed. If you watch some of the other earlier videos, you would have seen me showing that input action, unit events, and generic C# callbacks call performed when there's input, and then call canceled on a vector2 when the input is reduced to 0. So if I run this now, what we should see happening is the character won't stop when I release the keyboard. He'll actually just keep moving because we never receive the 0, 0. All we're looking at is the performed phase, which is triggered by the performed event. Sorry, invoked by the performed event. So if we wanted to have the character stop using this method, we would also need to subscribe to the canceled event. Similarly, with jump, because we're using the press interaction with the trigger behavior of press and release, we actually get 2 pressed events, one on press and one on release. But if we set this to press only, we would only get 1 event. But you would still get a canceled in both of these cases. So it's up to you whether you rely on interactions press, which is my preference, or you rely on the button actually being canceled correctly by this. I think it makes a lot more sense to use performed and then rely on the interactions if possible. But in this case, you get canceled. And now when we go back and play this, we should see that when I release, it stops, and we get another onMove phase cancel trigger false value 0, 0. Kind of the same thing here. Map use performed. I call the function on hold. Didn't comment out yet. And we'll get the same deal here, and we'll again subscribe to canceled here just to show the difference. So on use, we get a started, which we didn't subscribe to, and then we get a performed, and then when we release the button, we'll get a canceled. What I just showed there was important. The other phase of an event, of an input action, is started. So when we were using Unity events or generic C# events, we were just getting all of these, but when you just subscribe to them on your own, instead of using player input, you do have to manually subscribe to each of these. It's worth noting that in the to-do notes and the review notes for the input system, there were comments saying like, "Wow, it'd be really nice if we had one callback for all of these." So there may be one global one in the near future. But now when we use the use function, started, performed, and then we release, canceled. So use is a perfect case where you really want to be using events instead of just polling. So I'm going to comment these guys out and put some polling events in here because why not? So map use.phase, if map use.phase equals performed. We'll just spit a bunch of those in there. So this is a case where you would get a whole bunch of use, which you see use spam in here, as soon as the 2 seconds elapse. So when I push the button, you don't get anything because it's in the started phase. Let's do a switch case here instead. Started, performed, canceled, and waiting. And disabled is the phase that you get when the input action itself is disabled, but I'm not going to cover that in here. Started, use performed, use canceled, and use waiting. So what we'll see here is use waiting trips immediately. I'm just going to collapse that for a moment. And then when I hit use, we should see use has been started. After 2 seconds, you should be performed. What's going on there? Oh, pardon me. Waiting, started, performed gets spammed, and then I release. And I paused it really quickly because I wanted to show something also important here. When you're using event-based callbacks, you get a performed and then a canceled, and there's no on-waiting event because why? In the context of events, you really want to know when the event happens, not when it's waiting for something to happen. But we went from performed to waiting, and we did not get a canceled while we were polling. And this is important because in the event system, the input action goes from cancel to waiting instantly. It doesn't wait for another loop of fixed update or late update. It happens inside the input system. So if you're trying to poll for canceled for something like a button to determine when the button was lifted, so instead of on up, you would expect to see input action phase canceled, which is usually synonymous with on button up. It would never be called because it goes from performed to canceled to waiting within a single frame. It fires the event and then it goes back to waiting. So you'll never see a canceled inside of a fixed update or an update. And this is why it's really important that for things like buttons like jump or use, that you use the callback and you cache the event. Or you cache the variable and then process it when the next time your fixed update or update loop goes through. Okay, I hope that sheds a little bit of light on that. I will cover going back to player input using a similar method of enabling and disabling actions and registering events and why you do that in the next video. See ya.